Good afternoon, everybody. Today to our next webinar, we are going to talk about high performance I/O per second. So the systems which running, good random I/O and how to get the random I/O and how to have good performance. I guess this is not new for all of you. Cache solutions are available on the market since longer time. For example, LSI has already version 2. This is a SSD, so solid state disk based read and write cache. They provide option to make a RAID of the SSDs. This is why you are able to also use it as a write cache. What we are going to talk about today. So, few words about the controller, about the cache, how it works. We will also show live demo setup, how to create the CacheCade, how to create the RAID for the cache for the SSDs. Then we will make a very simple iSCSI volume on the DSS, and then we will use the IO meter to run performance test, and we will try to compare performance with and without cache, and we will try to show how it works with sequential and how it works with random. So our setup is very simple today. So we have a DSS V7. We can use also V6, but as the latest is V7, so this is why we are using V7. But in this case, there is no real difference. We will have the LSI RAID controller installed in data storage server, and we are using today Intel SSD. Yeah, so there is plenty different offers on the market, but for the caching and especially write oriented or so-called corporate enterprise oriented applications, you need to buy so-called reliable drives. So drives which your vendor guarantees some good so-called endurance, because SSDs has a known problem that the SSD, the flash cells, are able to get written only a limited number of times. So this is very important that the drive has a special chip which is making the proper wave labeling, means always writing the data into new space and managing this properly, so that the data are written equal in all cells, and because of the quite big capacity, you can get a very good write endurance, so even for more than 5 or even 10 years. Okay, so there are plenty solutions which are offering 3 or 5 years warranty already. Of course, for the you need to always ask for the which amount of data can be written in the warranty time. Okay, but these amounts are very good today, and it is already more than good even to plenty of different enterprise applications. Okay, so let me switch to another console where I have installed DSS. Okay, so DSS software is installed on the hardware where I have the LSI RAID controller. Okay, and I have already, I will show you what kind of drives I have here. So there are few drives available. One is SSD. One is a SAS drive, which I already made a drive on it, so there is a RAID array on it, and there are 2 SSD drives and there are few SATA drives. We can create the RAID using Open-E DSS web GUI, but we cannot create the CacheCade volume yet. So this is why you have to use Mega RAID software storage manager tool. So you can set the password to access the Mega RAID storage manager pool. You can set the password here. When you click on hardware RAID, then you have the option to set up a new password. If you do not set up new password, then the username will be just RAID and the password will be also RAID. Okay, so let us introduce the Mega RAID storage manager. So you need to download and set up on any Windows or any other operating system which Mega RAID storage manager is available, and then you will enter the IP. So that's my IP of my DSS. You can just enter here, and after discovering, it will show and list the DSS or some more DSS servers here, and that's the IP address. So now I just click on this IP address, and then I see the login window. So the username, as I mentioned, by default it's RAID, and the password is also RAID. I can of course change the password in the DSS GUI. Okay, so now we are connecting to the controller. It works similar when you will have the controller in your local system, and this is a just managing controller in the data storage software system. So we see when we start, we see the dashboard. We see the in the next tab we see the physical available devices, drives. Okay, and in the logical we can see already the configured RAID arrays and volumes, RAID volumes. In some cases you can create more virtual drives on one RAID set, but in our case we will just create one RAID set. That will be enough for our test. So as I mentioned, I have here, if I go to the physical, I have here one SAS drive, one single SAS drive, and I was configuring this as a kind of JBOD. So I was configuring here RAID 0 on top on the one single drive, right? And on this drive here, that's the drive. I have created a virtual drive with the exactly same capacity. So this is just kind of pass-through setup. Also in my system I have, as you see, one SSD and the second SSD here. So there is a SSD, very small one, Intel drive, just 30 gigabyte, two drives, and the two drives are minimum to configure write cache, because we can configure RAID one of these two SSD drives. So that's the SSD drive, and that's the second SSD drive. Okay. We have a few SATA drives here, small SATA drives, and we will. So there is 5 drives only, so we can see what kind of performance we can expect out of SATA drives and how we can improve using the SSD cache. So that's the logical view. In the physical view, we can see the drives. Okay, on the right mouse click, you can unconfigure, or you can set the parameters of the virtual drive. And in the dashboard, when I click on dashboard, we can see the options we have. So in order to use cache, or in order to use RAID 6 or some other advanced options, you need to get the license from LSI. So in our case, I'm just using a trial. So you see I have the Mega RAID CacheCade installed, and the factory installed RAID 6. We will use just maybe RAID 5, doesn't matter. And there is a fast path, so for the good I/O option also is installed here. So you need to make sure that the license for the CacheCade is there, then you can use it. Okay, so also you must see the option that you can create the virtual drive and you can create the CacheCade as well. Please remember that in many cases you need to use the refresh button. So on the top here there is a very nice button for refreshing. So after changing the settings will be not changed in the GUI immediately. So please always remember to click on this refresh. In this next icon, we can see the progress of the background tasks running, and we will see how it works soon, because when we create the RAID, then we will see the background initializing running. Okay, so you can also use this menu to show progress or to select the server. And very important thing is in the tools to configure alerts, right? You need to set up which alerts you want to configure to be sent to the DSS, because in the recent version we have changed the filter and we are not filtering anything from LSI RAID. So if you go to the setup administrator settings, and if you will configure the email notification, right? So email notification, so the events will be sent by email, right? Okay, this is unfortunately some delay. Okay, so you click on the send errors, and then when you configure to send the events or errors over the email, please remember that you need to go to the Mega RAID and select maybe some of them, select that you don't want to send them, right? Change individual events. When, for example, one of the warning or information will be coming very often as a spam, so you can disable to on logging this, right? You can just keep in MSM log. Okay, so now we are ready to create a virtual drive or create the CacheCade. We can start with creating a virtual drive, right? So I can click on this menu, and you have option simple or advanced. Better select advanced because we have more options, more influence on settings. So the very first option we are asked is RAID level. What kind of RAID set we are going to create. So in our case we are going to create RAID 5. Okay, and now next step, we need to select the drives which belongs to our RAID 5. So I just click on every one and then add button. So I'm clicking and selecting only SATA drives. You see the SSD drives are not available right now. Okay, so I have selected all available SATA drives, and now next step will be create the drive group. Okay, so we click on it, and then we can go to next menu. Okay, so after creating drive group, click on next, and then we see that the virtual drive will have such a default name. We can change it if we need it. That will be the capacity. Initializing, okay, we don't need to change it. Stripe size, we can leave default, and read policy, you can have always read ahead, and the write policy, this is very important. Write back means write cache, which is the regular write back cache for the RAID set. This is not the CacheCade. This is a cache which is using built-in RAM memory into RAID controller. This is working only if you have a battery backup unit, so BBU. In our case, the BBU is not installed, so I can just for testing I can say always RAID back. So it doesn't matter if BBU is working or not working, I will do the caching. For the demo purposes, this is good because we know that the cache works. We know how the best performance of this RAID array, what we can achieve. Here there is a few schools of setting this direct or cached I/O. In many cases, sometimes direct I/O is better, sometimes cached I/O. You need to run your application and change this and see what is giving you better results. Okay, read or write, of course that's the policy we are reading and writing, and cache for the drive. I'm using the cache for the drive, so the drive cache, which is mostly, let's say, 16, 32, 64 megabyte cache for the, which is directly on the drive, will be used as well. Okay, so now we are creating a virtual drive. We have a warning about RAID back mode and about the no battery. We are of course confirming this for our test purposes. Okay, and now next step. So we are ready to go to next step. We have summary here, and after clicking on finish, we see that the virtual drive was created successfully. When I click OK, now the question about using the BBU or not, we can just leave it enabled. Okay, so now when I go to logical, I still don't see it because this is not refreshing immediately, so I need to click on my refresh button, and after clicking refresh button I see that I have a RAID 5 configured, and that's the virtual drive, and the virtual drive is this RAID. This virtual drive is on top on the RAID 5, which is using all these SATA drives here, right? So next step will be SSD cache. So all these SSD drives which are available here, we can make the cache. So we go to dashboard back, and when I refresh it, okay, I see still there is no any background operation here. Okay, we can create the CacheCade right now. Okay, so the very first option is very similar like creating a regular virtual drive. We have option to make a RAID 0, so striped of 2 SSDs. This will be okay if we are going to use a read cache only, but when we are using also write cache, then unfortunately we need to select RAID 1 only. If we have, let's say, 4 drives, then there is option to select RAID 10. We need the mirror protection, because when you are writing to such a cache and this cache has a problem, means the drives failed, then the information which is on these cache drives is not maybe written yet to the regular RAID set, and then you can have the data corruption. This is why we have to use RAID 1 for write cache. Okay, so now I'm selecting the drives at first and at second. Both drives are selected, so now we are ready to create the drive group. Okay, so I'm clicking on drive group. That's done, and then we are now allowed to go to next step. So I click on the next button. That's the settings, that's the name of the CacheCade virtual drive. I can change it if I wish, and that the write policy is write back. So we are ready to create the virtual drive. Okay, so until virtual drive is not created, we are not able to go to next. So now create the virtual drive, and then next button is available. We go to next, and now finish. That's the summary. Okay, and we have message that the CacheCade virtual drive is successfully created. Okay, so again I go to logical. See, I don't see it yet, so I need to click on refresh. So at once I see new virtual drive, and that's the CacheCade virtual drive. So as we have enabled the cache option, so we see here this is enabled, so SSD caching. When we right mouse click on this, we can disable CacheCade. Okay, let me disable this. I need to confirm this operation. Okay, and again it is not refreshing, so I need to click on the refresh button, and after clicking on the refresh button I see that the CacheCade here is disabled. Okay, so we can enable this again. So enable SSD. Okay, again refresh. Okay, it is enabled again. So our tests we will start maybe with disabled SSD. So I will disable this again. Okay, refresh. No CacheCade. Good. So we have actually two units. We have the virtual drive on this SAS drive. We have a SATA RAID array, and we have CacheCade. So we have actually three units. When I go to DSS and to setup and the hardware RAID, so and then just refresh again here, it has a problem refreshing, so setup hardware RAID. Okay, so we have three virtual drives, right, as I mentioned. So LD0, that's the JBOD, that's the single drive, right? And then LD1, that's RAID 5. We see RAID 5 here, RAID 5 and the 5 drives here, and LD2, it is our RAID 1, okay, for CacheCade. Okay, that's the setup, and this setup will appear after refreshing in DSS. So when we go to configuration and volume manager, volume groups, then we have exported only the RAID 5, and we have exported the SSD. So the CacheCade is not exported yet. Okay, so I have a volume group created here because I was testing this before, and this volume group is not deleted, so it is there. If I want to start with from the beginning, I will need to go to console tools and delete the content of units. So I will have to go to there is no system volume because I was not properly removing the volume group before. So but it will need the reboot, so I will not do it right now. Let me create the volume group on the first drive, so we will save some time. On this SAS drive, and then we will have the test volume on VG01. So now it is preparing the volume group on the single drive, and it must create the system volume as well. Okay, let me see. So the drive was there. The drive is there because I was testing the drive in the past. So I will remove iSCSI drive, so there is nothing inside now. So and we are ready to create our iSCSI drive, right? So I'm selecting the type of the drive which I'm going to create. So this is iSCSI drive, and we have option just create the volume or just create with target. Okay, I can select creating with target automatically, so I will have less clicks. And I'm selecting block IO and the size. This is now very important thing. I will use 2 GB only. And why? Because in order to show CacheCade quick, we are not going to wait maybe 20-30 minutes or even a few hours to see the results. This is why if we want to show results very quick, I need a small volume. Having 2 GB only, the CacheCade is in the position to find so-called hot data in very short period of time. And if you will create in the normal production bigger drive, then of course the results, you will need to wait for results, sometimes even few hours. Okay, so we are creating iSCSI volumes. If there is something wrong or there is a problem with seeing this in the network, you can reset the connection. But please never do reset connection while server is running, because the initiators will lose the drive for the few seconds, and it can even hang applications. If there is nothing connected yet, so I will show you where is the reset. So you go to maintenance, connections, and you can reset the connections here. There is no connection, so when you click on reset, there is a restart of the iSCSI target. If there are connections, we will see the connections here. Okay, we will show this in a few seconds. So because I have created automatically, so the iSCSI target, when I go to target, the target is created already, and that was target 0, which was created automatically with my volume. So you see that's my 2 GB volume, and that's the target. The plus button is already clicked, so my target, my 2 GB size volume is exported over this target name. That's the target name here. And also we can see the target name when we scroll down. There is a rename function here, and you can see the target. If this target name is not as you wish, you can just change the name and apply. Okay, so the 2 gigabyte size volume is, let me log in one more time. You see, now there is no information about missing system volume because I was creating the new volume group. If you want to clean everything, then you go to Ctrl-Alt-X, or F1 button is showing you all the hotkey. So C is for Control, A is for Alt, and then you have a few so-called hotkeys. For example, Ctrl-Alt-X, Run Extended Tools. So I click Ctrl-Alt-X. Okay, then of course I need to enter my admin password, and then there will be delete content of units. So when I go to delete content of units, my password is admin, and then I can select which, with pressing with the space, I'm selecting what I want to clean, right? And when I want to clean, then I press OK, and in this case these volume groups and all logical volumes will be removed, and system it will ask for reboot. Of course you need to confirm the reboot. Okay, we will not delete it right now, only I wanted to show it to you how to do it once you want to clean the system. Okay, so now we can just go to iSCSI initiators. I have a Windows server here, so I have a iSCSI initiator. If you don't have the icon here, you can go to Start and click on, type iSCSI here, then you will find the initiator as well. So the iSCSI initiator I have already, because I was checking this before the webinar. So you see the initiator is already the discovery, the IP address was entered, so I can go to this and I can remove it. Okay, and you will need to enter the IP of your portal. So my DSS has a few different cards, and in the setup network administrator, okay, network interfaces, you see I'm connecting with 192.168.1.221, so that's ETH 0. Okay, and then I was connecting over another card, and that was ETH 5, so that's 192.168.6.221. How I can access this from my Windows? Okay, I need to add the alias. Okay, so when I go to Open Network Sharing Center and change adapter settings, okay, so that's the properties and in advanced I can see here the aliases. So you see I was adding the alias in subnet 6. This is why I was able to access this, right? Otherwise I need to stay in subnet 1. Okay, I have few other aliases to access different subnets. These settings is available only when you have a static IP. If you have a dynamic IP, you cannot set up more aliases. So please always use static if you want to access different subnets. Okay, so we can access this ETH5. So 192.168.6.221. Okay, and the port is default. Okay, so now when we go to targets and refresh, okay, the target is already listed here, so we need to connect to this target. So I click on connect, and when I have this add, it means it will be always starting after rebooting the Windows. So now you see it's connected. Okay, so that was the iSCSI connection. Now when we go to computer and manage, under manage we can see the disk management, and the very first thing you see, the disk is unknown, so we need to set up the master boot record. Okay, so now it's basic. If something wrong, it is not basic, so you need to go and put the drive online. Sometimes you will see the drive offline, okay, like this, so you need to right click and put online again. I don't need to partition the drive because I can use IOmeter with raw settings, and this works as well as a partition drive, so I will not need any test drive. So we have a disk in the system right now, so we are ready to start IOmeter. Okay, IOmeter, when I click on this, so we see the drive as a blue because it's not formatted. The formatted drives are shown as yellow, and if there is an IOBW test file, so I can see yellow and not strike, so I can use the drive at once for testing. So in this case I'm select worker 1 and I'm clicking on the drive, so I'm selecting this drive, and for the worker 2 I do the same and click on this drive. So I will make the test with 2 workers. Now I select the host, okay, and now all the settings which I apply will be applied to both workers. So now let's say outstanding IO, let's say 16 outstanding IO, and access specification. So we can select one of them, or we can select new and untitled, because I'm not really focused on making documentation here. So let us see how the RAID array behave when we are testing. You know, in many publications you need the high performance, so you can put 64 or even more kilobytes per second. You will select sequential, and then let's say 100% read or 100% write, doesn't matter. And okay, that's my pattern. I add, okay, and when I click on this icon, we will start the test. When I click on save, I will save results, or cancel, I will not save the results. Okay, and the result display, okay, we can just see the performance, writing performance on my RAID array. The RAID array is showing something like 1000, 300, 400 IO, not really very good. And what's going on? Let us see. We have the background task which is running in the background, so I can do the refresh. So we see that it was already something like 7% completed. When I click on this next icon, I will see more details, that it's 17 times elapsed and then still 3 hours. So even the background initializing work, my IOmeter is on sequential, is showing quite good performance, right? So let us stop the test, remove, and then edit. Okay, let us do the sequential read test. Okay, even initializing, the results are quite nice. You see, on reading there is not really delay. I have a 110 megabytes per second. That's mostly what over 1 gigabit Ethernet is expected. In order to see more I/O, I can change the smaller block size. Let's say I will put instead of 64 it was 1400, something like this. I will put, let's say, 32. Okay, cancel. I don't need the results. You see the number of I/O is now 3400 or 3500, right? Because it's a smaller block size. We can change the I/O, block size, let's say, to 4K. Okay. You see now we see the 14,000 or something. Probably there is a bottleneck now on the I/O size, on the number of I/O with this small block size, right? So with the sequential pattern we can go to quite good I/O, but what's going on when I'm going to put 100% random? Okay, let's say I put even a smaller block, so 2K, 100% random and 100% read. What's going on now? Okay, so you see, instead of a very nice number of I/O, we are dropping down to even not 500, or maybe 500 from time to time. I can click on last update to see the current number of I/O on the current total megabytes per second. So you see, in such case, SATA drives showing very poor performance. SATA drives are very bad for random I/O. If I will have fast SAS drives, I can expect few times better, at least 3, 4, 5 times better performance here. Also, the bigger number of drives is working well. So in many cases, people were solving the random I/O problem with adding a bigger number of drives into RAID array, maybe 16 or even 24 drives, giving you scaling I/O performance. Of course, sequential performance as well. That was the solution. Today, as the SSD drives are coming with a good endurance, so they are reliable, and random performance is as good as a sequential. So this is why you can create a RAID using only SSD, or if you are budget oriented, you can try this kind of cache as we are presenting today. So let us stop the background initializing. The background initializing has some influence, but actually we don't want to have any influence. We can normally wait, let's say 3-4 hours, and make it initialized fully. But now let me see close. I will refresh one more time and click on my icon. Now it's 8% when I click on suspend. Okay, so now the background task is paused for the time until I will resume. So when I close and when I refresh again and when I go here, I have resume button, right? But I'm not going to resume the operation right now. I'm going to see what's going on with my I/O. Okay, still maybe a bit better, but still in much below 1000. So let us set the 16,000 here, what I can expect after having a cache. So okay, now I go to the logical and right mouse click and click on enable SSD caching. Okay, so I'm enabling SSD caching, and in order to make sure that it is enabled, I will just refresh then we see it's enabled, and then let us see what's going on with our number of I/O. So I see some questions. Make it okay, 2 megabytes. I'm making 2 gigabyte the RAID array. Okay. So now the CacheCade algorithm is trying to find so-called hot data, and it will try to access this hot data instead of data which are on the RAID. This process takes some time, and as I mentioned, if you will have, let's say, 200 gig drive, you may maybe wait few hours until you will have the full performance. Of course, the array need to be initialized, because when array is initializing, then you will see lower performance. This is why I stopped the background initializing. So we see that the algorithm is learning already, and the I/O goes up. So I'm expecting with this setup, with these cards, with of course with the 10 gig Ethernet is lower latency. With the faster SSD you can have also better performance. I'm using quite old SSD, not the fastest one. So here I'm reaching something like, you know, almost 16,000 I/O per second, and this really works. I will remove the trace for the few times. So you see it is just coming in this range. And what happened when I disable the caching again? Then we will see, of course, we must see the drop. So I'm disabling the SSD caching, confirm, and then what's going on? Of course, the performance drop again. Let me refresh to see that it's really disabled, right? And when I enable this again, okay, then we will see that the algorithm needs to learn again to find the hot data, and then getting the maximum performance which we expect here. So that is the proof that this CacheCade is helping us a lot in case of the number of I/O. But with number of I/O, with this very small block, of course you will see also better performance in the in overall total megabytes per second. As number of I/O is growing, then of course the total megabyte per second is growing as well, right? We are using a quite not nice pattern for the SATA. SATA doesn't like this pattern at all. So when you do 100% RAID and the 2K block only, then the SATA drives is showing the worst, right? In the SAS drive, let's say with 10,000 or 15,000 RPM, the average access time is much better, because in SATA you will have average access time maybe 9 or 10, 12, maybe even more milliseconds. In SAS 15,000 RPM you have even 3 milliseconds. So this is why you have so many I/O with SATA, with SAS drives. So here you see we reach the almost maximum. So now we reach also 30 megabytes per second, right? So when I click on okay, stop and start, so that's the performance. And you see without CacheCade I was in range of 1 megabyte or even below, and now I'm in range of 30 megabytes. So that's a small change, not a big investment, and a big difference in reading performance. In writing performance you may expect also much better results. Let me see, there is a question to help measure if the SSD cache is big enough, is it possible to monitor the percentage of cache hits by SNMP or similar? Yes, the monitoring of the cache is possible, but here I must say I was not digging in this area yet, so I will check it and I will answer you after the webinar. Please be so kind and send me the email reminder about this. Okay, there is also many different things which are very interesting, and many stuff it's available in smart data, because probably you will need to read the smart data in order to monitor your SSDs. In smart you may find information how long your drive will be still alive, because as I mentioned about endurance, when you will write all the information which the manufacturer was predicting that the drive will be available, then you may see that some cells will be already killed and the drive will be just slowly dying, getting less and less, and maybe have some data corruptions, and that's it. So you really need to make sure what kind of data will be written to the RAID array. Is it daily, let's say 100 gig, or daily 1 gig, or daily maybe 1 terabyte? If this is 1 terabyte daily, so you need to really think about buying plenty of drives and a bigger capacity and the best endurance available. Of course, such drives are much more expensive than the regular consumer drive. Okay, so let us make a small test with the writing. So I will just stop the okay, the cache is now, let me see, I need to always refresh. A cache was enabled. Okay, so let me disable the cache. Okay, so disable and refresh. So now I know the cache is disabled. Let me change this pattern to, maybe I will just create a new one. So new one is always default, having a 33% write, 67 read, and the 2K block size with the 100% random. The default pattern is showing very poor results, mostly on the SATA drives. So let us start this test. Okay, so we see only 1.6, 1.5 megabyte per second. Sometimes even worse than 1 megabyte per second. It's even worse. So we are something in maybe 300-500 IO. So that's really poor. Let us see what's going on when I'm enabling the cache. Okay, and refresh to make sure that the cache is enabled. So it takes some time. Okay, it's enabled, and now we can see what's going on with our performance. Of course, reading and writing is already not so nice pattern as reading only. It may take probably almost the same time for the algorithm to learn about hot data, and we can expect, I will just put to last update. It will be just the exactly this what okay, this is exactly what it happens at the time. So we see the performance is already showing us much better results than without CacheCade, and with CacheCade we were below 1 or 1, and now we are with 20. So it is obvious improvement. And again, when you will have the bigger drive, let's say 100, 200 gig, you may wait for the results some time, but when you will just make a statistic of your and the user experience, you will see that the user experience will be very positive, because in many cases users are mostly using a certain set of data at a certain time, and this is changing not so often. So that was the presentation. Let me see if there are some other more questions. I don't see any more questions. So I'm done with the setup. I would like to thank you very much for your time, for joining us, and I wish you good performance systems and happy customers with the CacheCade. Please buy a bit faster drives than my drives, and also when you are using 10 gig connections, then will be lower latency than on 1 gig, and then you can have also a better I/O. So one more time, thank you very much. Oh, I see if we build, next question, if we build an SSD of 1 terabyte with SLC, what will be the IOPS? So if this will be, of course, without the CacheCade, just drives, this depends how you will connect. When you will connect with the iSCSI 10 gig, you can expect maybe 60,000 I/O. When you will connect with fiber channel, you can expect more than 100,000 I/O. Okay, my email, yes, I will write you my email. So this, okay, okay, that's my email. Okay, so thank you very much for joining the webinar today, and please visit our web and see what is the next webinar. And I hope you to have you soon on the next webinar. So thank you very much, and bye.